The law of cosines comes to us as three sets of equations. Now, you will be provided with one of these equations, but that's enough for you to get any of them. They follow the same pattern. So you don't need to memorize, by the way, the law of sines, and you don't need to memorize the law of cosines. I'm just letting you know that the law of cosines will be given to you in the form of just having one of these equations. So here's how it works. The law of cosines basically is how we say, all right, we don't have a right triangle, so we can't use Pythagoras, but we have something kind of close. I mean, each of these equations kind of looks like Pythagoras, but then we have this extra junk on at the end, right? So here's how it works. You write down like Pythagoras. In fact, let's start at the bottom because that's one that looks most like Pythagoras in terms of our naming conventions on the sides. So c squared is equal to a squared plus b squared. That's true if it's a right triangle, but for any triangle at all, it's still true if we subtract off the product 2ab times cosine of c. What's important to note is that on the right side of, the busy side here, this is the product 2 times a times b, the same sides that were used in the sum of the squares. And this angle is always opposite that side on the other side of the equation. You don't have to memorize this, but I'm just letting you know what you do need to do is I'm going to give you one of these, and you need to know how to adjust it if you need to get any of the other forms. So the law of cosines will help us solve triangles that are these other two cases. Maybe I know two sides in the included angle. Note that if I know two sides in the included angle, I don't have an angle side pair, right, that the law of sines would apply to. And if I know all three sides, if I know no angles at all, but I know all three sides, I can use law of cosines. So, a quick note about case 4, because we're using law of cosines just to find the angles, right? Like if we know all three sides, the angles are the only things we need to find. Always start by finding the biggest angle first, if you have a choice, because arc cosine will return an angle between 0 and 180. Arc cosine can return an obtuse angle, even though arc sine cannot. So if you're going to use law of cosines to find an angle and you have a choice, find the one you know is bigger, right? And we know that a bigger angle is opposite a longer side. All right. So, case 3, two sides in the included angle. That's exactly what they've given us here. They were nice enough in this problem. They gave us the included angle, or the known angle that they gave us is obtuse. I know that there does not exist another obtuse angle here, and that's always nice to know. But we're going to start out by finding side B, I think, because the law of cosines tells us that b squared is equal to a squared plus c squared. So there's the sort of pseudo-Pythagoras. But then I have to subtract off 2ac times cosine of b. I know sides A and C, and I know angle B. So basically, I have everything I need to find b squared, and then we'll just plug stuff in and take the square root. So 0.1672 squared. You can put this whole thing under the radical, just, use parentheses. Be careful. Or you can you can also just obviously compute this first and then take the square root at the end. So we have 0.1672 squared plus 0.5143. So everybody's plugging stuff into their calculator, and I am shouting out random numbers. I'm sorry about that. Let me stop. 0.6317. 6317.
Numbers are hard.
What's that? Numbers are hard, yeah. Before I go any further, the side we found is larger than the two sides they provided us with. Does that seem right to us?
Yeah, that makes sense.
Why?
Because B is the largest angle.
B has to be the even though they didn't give us any other angles, it has to be the largest one because a triangle cannot possibly have more than one obtuse angle. Yeah, so we definitely have B. Now that we have B, we can find angles A and C. We could do this using law of cosines, but since we now have an angle and its side opposite, we can do this using law of sines, which might be a little simpler. So let's say we want to solve for, I don't know, angle A. If we're going to solve for angle A using law of sines, then, because I have plenty of space, so I'll come down here. Then it would look like A over sine of A is equal to B over sine of B. So 0.1672 over sine of A is equal to 0.6317 over sine of 128.3. Use the cross product. And solve for sine of A first. And then we'll just use the arc sine. I know the arc sine will give me the angle I'm looking for because the remaining angles, including angle A here, has to be acute. So 11.99, or, oh, we're finding an angle, so maybe I'll call that 12.0. Now what's left to find?
C.
Yeah, and this one's easy enough since we know the other two angles. $39.7. All right. There it is. How awesome is that? Yay. One more? So here they've given us all three sides, but no angles. So obviously we have to start out finding an angle. And we're going to use the law of cosines for this. Can somebody tell me why we cannot use the law of sines to find an angle?
Because you need a match pair.
Yeah, we need a side and its opposite angle. We have no angles, so law of sines is out the window. And who wants to tell me which angle we should solve for first? What would be, what's that? Why A?
Because it's the biggest one.
We know it's the biggest one because?
It has the longest corresponding.
Yeah, it's opposite. Yeah, exactly. It's opposite the longest side. So I always start by finding the biggest angle. That way, if there is an obtuse angle, I've found it, and any of the other angles that I could find, I could proceed by using arc sine or the law of sines, and I know that it won't lead me astray. So let's see. If we're going to solve for angle A using law of cosines, what I need is the version of the law of cosines that has cosine of A in it, and that's the one that begins with A squared equals. So A squared equals B squared plus C squared minus 2BC times cosine of A. Now we're going to solve for angle A, knowing all three sides. It's going to involve like a bunch of algebra and rearranging stuff. I think it's easier to do it before plugging numbers in. So I'm just going to do the algebra on this formula. So the first thing I'll do is just maybe isolate the 2BC cosine of A. So in fact, if we add 2BC cosine of A and subtract A squared from both sides, and we have 2BC times cosine of A is equal to B squared plus C squared minus A squared. And then we can divide by 2BC. I'm going to pause here for a moment and just see if there are questions on how we got this far. Okay. So now if we know cosine of A, we get angle A just by taking the arc cosine of this fraction. Now you can, and I will demonstrate, or the way I'll do it is by plugging the whole expression into the arc cosine. Some people prefer to just do the arithmetic on the fraction, just figure out what this is as a number, and then take arc cosine of that. Just because you have to be careful with your parentheses. I mean, either way is fine. But note that when you're solving for an angle this way, one of the common errors could be a failure to use parentheses where they belong. If this fraction, just without taking arc cosine or even considering sine, but just what this fraction ends up being equal to, if it is bigger than 1 or less than -1, arc cosine will return an error because cosine has to be between 1 and -1. And if that happens, and then you get that, it'll return a domain error. It means double check how you're evaluating this on the calculator. So we have 22.62 squared plus 42.27 squared, minus 51.43 squared, all over So here's what's absolutely crucial if you're plugging the whole thing into the calculator like this. You have a whole set of parentheses around the stuff on top, and you do need a whole set of parentheses around the stuff on the bottom to make sure it divides by the whole product. And what did I do? I start off without a set of parentheses. I'm closing the parentheses on the top, divide, opening a set of parentheses to put that product in. Closing the parentheses on the denominator, closing the parentheses on the arc sine, or the arc cosine. And I get 100.4 degrees. How's that? I feel like so I know that this is like, it's just after lunch and we're like, whatever, let's just get it over with and we're almost at the end of class, but there's usually some questions or maybe somebody whose calculator did not give them the correct value. I just want to make sure that if anybody has questions on this example, that they do in fact ask. What? Well, yeah, I mean, that might be an oversimplification because people this throws the errors all the time. Like, you have to be vigilant with your parentheses. Okay. If you find that you're doing this type of problem, we're using arc cosine, right? Like the law of cosines to get an angle, and it throws an error, go back to this step here and just calculate this as a number and see if it gives you something greater than 1 or less than 1. If it does that, then there might be an issue. So we have angle A. Huzzah! What now?
It's the law of sines to find another angle.
Yeah, and we should know, you can use the law of cosines to find each angle, right? You could just go through this whole process over and over and over again. But of course, it is easier to just use the law of sines to get the next one. That's why we were so clever in choosing what we knew to be the largest angle first. So let's find, which angle do you want to do next?
C.
C, okay. So then we know C over sine of C. Oops. God. C is equal to, and then we have to use A and sine A because that's our known pair. So we have 42.27 over sine of C is equal to 51.43 over sine of 100.4 degrees. Little cross product. And dividing through by 5143 tells us that sine of C is equal to this fraction. And so we just take arcsine. $53.9. And now it's all over but the shouting.
Prime angle B.
Yeah. We don't need law of cosines or law of sines because we know the other two angles. 25.7. Huzzah. So we had another example in the law of cosine section. We want to solve this triangle. They gave us an angle and the adjacent sides, right? Like, or they say two sides in the included angle. That's what we have. And if we have two sides in the included angle, usually here we would start by using law of cosines to find the side opposite that known angle. And the law of cosines says c squared equals a squared plus b squared. It's the one that starts out looking like Pythagoras, but then you have to subtract off 2ab times cosine of c. And the stuff on the right side of the equation is all stuff that we know, right? That's all stuff that we're given. So c squared is 29.7 squared plus 44.2 squared minus 2 times 29.7 times 44.2 times cosine of 35 degrees. And then, you know, square roots and whatever. You got to make sure if you're putting this whole thing in the square root that you put like parentheses around the whole thing so that the whole thing is under a radical. My fingers don't work today, just so you know. So I'm gonna be behind you guys. Do you have it yet?
26.2.
26.2? Okay. Good. Then I don't need to do it. So we know side C, 26.2. We have two things left to find. They are angle A and angle B. For one of these angles, we need to use law of cosines to solve. Well, technically, because we have a matched, like an angle on the side opposite, we could use law of sines. I don't recommend it in this situation because the angle they gave us is acute. That means that one of the remaining angles could be obtuse, right? And so if you really want to use law of sines, make sure that you use law of sines to find an acute angle. Like you would have to use it to find angle A. Arc sine will never give you an obtuse angle. In a million years, it's just not going to do it. Arc cosine will give you an obtuse angle. It'll give you any angle from 0 to 180. So that's why in this example, I think my next step is I'm going to use law of cosines to solve this. Then I'll know that I've got that obtuse angle, if it is obtuse. I mean, it looks like it is, but I know that that's the biggest angle because it is opposite the longest side. So if I write the law of cosines, the law of cosines that uses angle B is the one that starts out b squared equals a squared plus c squared minus 2ac times cosine of b. We know all the sides, and let's say I like doing the algebra at the outset so I don't have to like write down all these digits a million times. So I'm going to add 2ac times cosine of b to both sides, and I'm going to subtract b squared. So 2ac times cosine of b is equal to a squared plus c squared minus b squared, and then we divide. That means that cosine of b is equal to a squared plus c squared minus b squared over 2ac. And now I'll go ahead and plug in those numbers. So a squared is 29.7 squared plus 26.2 squared minus 44.2 squared all over 2 times 29.7 times 26.2. This is cosine of b. Now, when it comes to like needing to be careful with the calculator, this is one type of calculation that has many opportunities to make mistakes. If you're going to take arc cosine of the whole thing, we talked about this last time, you got to make sure that you put the whole numerator in parentheses and also the whole denominator. Even though there's not addition or subtraction, you got to put the whole denominator in parentheses, otherwise it will treat it as though these are factors that belong on top. Alternatively, you could just do out this calculation. You'll still need the parentheses where they belong. But as a quick check, sometimes when you're doing this calculation, it might give you a domain error. That's with the law of cosines. The most likely cause of that is some error in plugging things into the calculator. And if that happens, the next thing you should do is just figure out what is this fraction equal to. So if we did that here, 29.7 squared
plus 26.2 squared minus 44.2 squared.
and then 2 times, is it 29.7 and 26.2?
Yes.
So the parentheses around the top, parentheses around the bottom, I'm dividing. This value has to be between -1 and 1. Right? We know it's impossible for cosine to throw out a value that's bigger than 1 or less than -1. And so when you get a domain error, that's what it's telling you. Oh, you asked me to find arc cosine of something that's outside the range. And so usually, I think the most common culprit when that happens with the arc cosine, when that happens with the law of cosines problems, is that there was just an error in how you plugged it into the calculator. So we have minus 0.2475. So B is arc cosine of that. The sign is super important here. The fact that it's negative, that's how I know it's actually going to spit out an obtuse angle. So 104.3. Yeah. Looking at this triangle and sort of the order in which we're approaching this, it would be, you know, we talked about, and I guess I kind of gave my preference of what I usually do here is not use a law of sines in this situation because it cannot give an obtuse angle. It would be legitimate if somebody said, look, I know if there's an obtuse angle, it would have to be B, so I'll just use law of sines to solve for A. That has to be acute. Totally legitimate. Like, there's absolutely nothing wrong with doing that. Just make sure you put some thought into what situation am I in, and am I guaranteed that I'm solving for an acute angle here when you use law of sines. And then, the only thing left is angle A. So we just subtract from 180. What do we get? 40.7? Oops. 40. Because if you get 104.3 for the big angle, You're subtracting a 0.3 off, so you'd have a 0.7 at the end, right?